Hello, my name is Mike Orlett. I'm a project manager at Material Sciences Corporation in Horsham, Pennsylvania, and I'm here to talk to you about the SBIR topic, Lightweight Durable FOD Screen for Air-Cushioned Vehicles. First, I'd like to talk about the background of Material Sciences. We were formed in 1970 by some of the early leaders of fiber-reinforced composite mechanics. And through the 70s and 80s, we were consistently on the forefront of numerical analysis of composites on the micro and the structural scale. Starting in the 90s, MSC began to see a need from our customers, especially the U.S. Navy, to add materials testing and prototyping to the services we offered. This included generating design allowables for major Navy programs such as the composite DDG 1000 deckhouse, as well as bow domes and sonar domes for the Navy. Starting about 2010, MSC started adding composite component manufacturing to the offerings and eventually merged with our longtime partners at Siemens Composites in Gulfport, Mississippi, who manufacture large-scale composites using the Siemens Composites resin infusion molding process. Also, during that time, MSC added its own manufacturing plant in Greenville, South Carolina, which currently produces medium-sized marine structures for the Navy and system integrators, using out-of-autoclave molding processes. We also have an industrial weaving facility with the ability to produce custom composite reinforcement and custom performance fabrics. Today, we're still headquartered in Horsham, Pennsylvania, where we perform analysis, design, testing, and prototyping, and specializing in small-scale manufacturing, while the bulk of our larger components are fabricated in Greenville, and we still support Siemens Composites in Gulfport. We also have an office in Huntsville, Alabama, which provides testing, repair, and prototyping to the Army Missile R&D Group at the Redstone Arsenal. Throughout the 50-year history of MSC, the overarching product of MSC has been material and engineering problem solving for the DoD customer. The SBIR program I'm here to discuss deals with the replacement of the foreign object and debris screen, which covers the front of the propeller duct on the two thrusters seen in the picture. Current product is this welded stainless steel structure with stainless steel wire rope nettings, which allows airflow while catching objects down to a 4-inch diameter. The structure can be disassembled into 3 parts so that it does not require removal of the drive shaft for installation. The primary threats that the FOD screen protects against are bird strikes and debris from unsecured cargo. The program goal is to develop a composite FOD screen which can meet the current airflow, impact, and sand-water environmental requirements while achieving a 10% or more weight reduction. The transition target is the legacy Navy LCACs and the newer version called the ship-to-shore connector. This part will be a form-fit function replacement for the current product. The primary operational improvement that the customer seeks is weight reduction in order to increase the fuel and payload capacity. It is important to keep in mind that the FOD screen is a critical component of the propulsion system, and that failure of the screen under impact could cause catastrophic damage to the thrust system, disabling the craft. Another important operational feature is the airflow to the propeller, which, if decreased, can affect the craft's performance and efficiency. The current product is a welded stainless steel structure and is both heavy and extremely costly due to the labor costs of welding all the pieces together. However, it's also very mechanically and environmentally robust, especially when it comes to resisting sand and water erosion. This is one of the challenges of the composite FOD screen, which is corrosion resistant but must be protected from sand erosion. MSC has been working with the Naval Surface Warfare Center at Panama City, the Engineering Center for Air-Cushioned Vehicles, on developing sandproof coatings for other components on the LCAC, and believe we have also come up with a solution for the FOD screen. From the beginning, the plan was to use a composite structure shaped similarly to the existing steel structure, with the eventual focus becoming the conical shape that you see here. In addition to changing the steel members to composite, MSC is planning to use synthetic ropes coated in a polymer jacket for the net structure. The shape and structure are largely dictated by the airflow requirements which lead to very slender beams that have little strength transverse to the impact direction. But through a long process of analysis and sub-element testing, MSC was able to design a structure which meets the factors of safety under impact conditions, the most severe of which is bird strike. As many people know, steel is real when it comes to absorbing large amounts of energy. The current alloy, 316 stainless, is known for both corrosion resistance and ductility, and that ductility allows steel structures to absorb large amounts of energy in collisions by plastic deformation. The saving feature here is that a bird strike is not a car crash. The high strength and lower stiffness of the composite material allows it to absorb energy like a spring rather than through ductility. In fact, it deflects much more than steel structure without breaking. In this case, the lightweight nature of the composite is actually a negative, but we were able to come up with a design that meets the requirements and saves over 25% of the weight compared to the steel structure. Another plus of the design is that the flat composite structure is simple to manufacture using large panels that are water jet cut. MSC has shown through testing and analysis that bonded joints using injection molded connectors can provide the strength needed for all load cases and requires much less labor than welding. Last winter, MSC completed the first year of the SBIR, which consisted of virtual design, performing sub-element structural tests, and sand erosion survivability testing. We are currently building the full-scale test article, which will be instrumented during impact testing to simulate bird strike, which will be a lot of fun. After the testing, MSC will spend the rest of the second year analyzing and redesigning and planning for additional test articles to be field tested, either at the fully functional propeller test stand at Panama City or on a working hovercraft during the third year option if it's awarded. Again, the key feature of the new screen is weight reduction. The goal was a 10% reduction, and because of airflow, we really can't add much material. So we're looking at more of a 25% reduction in weight. Now everybody thinks of composites to be high cost compared to steel, but the simplicity of assembly and labor costs place us well below the threshold of being cost neutral. An added benefit of lightweighting the design is the installation removal process. Because the part is assembled from 3 components, the composite screen is on the cusp of being light enough to be installed without requiring any lift equipment. The critical path, again, for the transition of this product to reality is to verify that the composite structure maintains the reliability and longevity compared to the stainless steel structure. The transition to the fleet is straightforward. Pending a successful demonstration on the test stand or craft, the short-term plan would require procurement from the Navy to field a ship set of products for long-term evaluation. MSC is familiar with both the acquisition and engineering group for PMS 377 through prior projects and have a track record of providing components for a retrofit on existing craft, likely a training craft. At best, we would be looking at the 2024 timeframe for delivery. The final step for transition would be an engineering change order where the integrator, Textron, or maintenance contractors for the amphibious combat units would be instructed to purchase composite screens from MSC. In order to determine what broader market this technology could serve, there are 2 aspects to consider. First is the actual design, which is the form, fit, and function replacement of the LCAC FOD screen, which obviously has a limited market. However, the second aspect is to look at the core technologies developed here. First, you have the physics-based design methodology, which matches the structure's spring stiffness to optimally match the impact energy and momentum of the strike in order to avoid local damage to the frame elements. This can be applied to various protective structures. Second is the material and manufacturing technologies developed here, namely building a dome structure from 2D composite panels and reinforced plastic connectors connected with a laced net. Using these technologies, there are various offshoots to which it can be applied, both with impact protection structures such as for wind turbines, commercial hovercraft, and protection of exposed shipboard structures. Such applications would have different airflow requirements and different sizes, but the same stick and connector approach could be applied given this manufacturing method's capability of fast build and design cycles. For the transition to the fleet, MSC has the in-house manufacturing capability to support the needs of the LCAC fleet now and into the future without additional subcontractors or suppliers. The key partnership for transition would be the current integrator, which happens to also be the manufacturer of the current FOD screens. In other words, we would have to convince the Navy customer to require the integrator to outsource this component, again emphasizing the need for significant performance increase and maintaining quality and reliability. Transitioning to a wider market for Navy craft, MSC would focus on new opportunities within NAVSEA program offices with an emphasis on some of the small craft Navy community. That concludes my presentation, so feel free to hover on over to see me at the Sea, Air, and Space booth. I'll be there on Monday, April 4th. Just want to wrap up again. MSC is an AS91 certified provider of composite structures for the Navy and other DoD and commercial clients. We're headquartered in Horsham, Pennsylvania. Feel free to give me a call. We have manufacturing centers in Greenville, South Carolina, and Huntsville, Alabama as well. And like we always say, from math to manufacturing, MSC can figure it out. Thank you.